Hello, dividers. Big day here. We've got 5,234 divided by 9. You don't know that one. I don't know what. Oh, maybe you do. I don't know that one. So I'm going to put it in a long division symbol, which is often called the house. My divisor, which is the number that's doing the dividing, is going to go on the doorstep right in the front, and it'll be 9 goes into my dividend. And this is my dividend. So 9 goes into 5. Can you believe that somebody called me on a holiday? It was Mrs. Sovell. 9 goes into 5,234, and we're going to use alternate algorithm right now. So I'm going to draw this long line down here. And one of the things I'm going to need to know is my multiples of 10. So I know that 9 times 10 is 900. Let me back this up a little bit. 9, oh, that's not right. Okay, sorry. I should just start this all over. Maybe I'll learn how to edit. We know that 9 times 10 is 90. 9 times 100 is 900. 9 times 1,000 is 9,000, right? 9,000 seems way too big for this problem. But I could come over here and say, I think 9 will go into 5,234 100 times. Because I know that 9 times 100 is 900. So I'll write my 900 right here, and I'll subtract. 4 minus 0, 3 minus 0, 2 minus 9. That's a little tougher. 12 minus 9, and 4. So I have 4,334 left. How about another 100? I think it can go in another 100 times. 4 minus 0, 3 minus 0, 3 minus 9, 13 minus 9. Another 100 times? Does anybody have another idea? If 9 times 100 is 900, I wonder what 9 times 200 would be. And we know that it's really 9 times 2 is 18, 0, 0. 1,800. Should I try that? I know what you're thinking. You're saying, no, go 300. Go 300. Well, I could do that, but I'm going to try 200 for right now. 9 times 200 is 1,800. Another bit of subtraction. 4 minus 0, 3 minus 0, 4 minus 8, 14 minus 8, 2 minus 1. I guess I'm back to 100 because 9 times 200 would be larger. 1,800 is larger, so I'm going to go back to 100. I know what you were thinking. You were saying, why don't you put it in 300 times? Well, you know what? That would have been really good thinking. But if you don't catch on to that when you're there, remember that you're still going to get the right answer with this method, and that's why it's worth knowing. 6 minus 9. 16 minus 9, 734. I'm going to need to use something different than 100. I could use 9 times 10 right now. I wonder if I could use 9 times 20, or 9 times 30, or 9 times 40. What do you think? What if I did 9 times 50? 50 is a multiple of 10. That's like saying 9 times 5 is 45. But it's really 9 times 50, which is 450. I know some of you are saying, no, go more, go higher. But I'm going to stick with 9 times 50 for right now, just to show how this process works. So 9 times 50 is 450. 13 minus 5 is 8, right? And 6 minus 4 is 2. So now now the problem with this algorithm is all the subtraction. It's easy to make a mistake with subtraction. So you'd be wise if you checked your work, like 4 plus 0 is 4, and 8 plus 5 is 13. There's my 1, okay? And 2 plus 4 is 6, plus that 1 is 7. Yeah, I'm doing okay. But this is where you can go wrong with this one. Now, how many times can 9 go into 284? I know that 9 times 10 is 90. What about 9 times 20? That should be 180. What about 9 times 30? 9 times 30. 9 times 30. Hang on. Gotta get my machine rolling here. 9 times 30 should be 9 times, you don't need to do this, right? 9 times 30 is 27 plus 0. So we're going to say minus 270. 4 minus 0, 8 minus 7. Does 9 go into 14? One time. So I'm beyond multiples of 10 when I get down to my single-digit divisors. 14 minus 9 is 5. 5 is less than 9, so this must be a remainder of 5. I'm going to bring my remainder of 5 down here and forget about it for a minute, okay? I need to add all the times that 9 went into this, so I'd have 100 plus 100, that's 200, plus 200, that's 400, plus 100, that's 500, plus 50, it's 550, plus 30 is 580, plus 1 is 581. And of course you could do this as a column addition, except for my column doesn't all fit on the screen, so I'm having to keep it in my head. Looks to me like that's 581 remainder of 5. Let's check our work, because that's really important, and you can never forget about it, okay? So 581 times 9. 9 times 1 is 9. 9 times 8 is 72. 9 times 5 is 45. Plus 7 is 52. Uh-oh, that is not the number we started with. Oh yeah, that's right. We had a remainder of 5. So can I scroll down anymore? Come on, I need to scroll down just a little more. 9 plus 5 is 14. 3, 2, 5. This is this math problem. And let's see if that's what we started with. If it was 5,234. When I say it's super important to check your work, it's because it's so easy to make errors in long division. 5,234, that's what we started with. This is called partial products division. It can be long, it can be short. The better you get at it, the shorter it is. But it's a great way to approach a long division problem that you're having trouble with, because you really can't go wrong.